Hey, physical science students, this is Mr. Lambert here. Let's talk about temperature, thermal energy, and heat. Just as a reminder, we are starting lesson 12 with this video. We are in chapter 5 of the textbook, which will be posted, covering section 5.1 at the moment. I'm going to try to sneak in section 5.2 as well. Pages 138 to 143 of the textbook, temperature, thermal energy, and heat. Oftentimes we say things are hot or cold, and we often link the terms heat and temperature. We think they're the same. In the world of physics, they are not the same. Before I talk about the definition here, I want to, I'm going to use a prop and show you this thermometer here. Why does the thermometer go up or down when it's hot or cold? What is really happening? If you think about it, it's all about particles. It's all about how little tiny particles of air, in this particular case, are moving. If the particles of air are moving extremely fast, they're going to be smashing into this bulb right here, which makes the pressure in the bulb go up. So that's going to raise the liquid. It's alcohol thermometer. But the point is, it's all about the motion of particles. What is temperature? Temperature is defined in your book as the average kinetic energy, a measurement of the average kinetic energy of the particles that make up an object. It's how much the particles are moving on average. Once again, with the thermometer, you have particles slamming into this. We can't see them, but we know that they are. If they were moving faster, if the particles were moving faster, let's say hot air, that would make the temperature increase. But again, temperature and heat aren't, they're not the same thing. Here are the units of temperature that are often used in science classes in the United States. We all know that we use degrees Fahrenheit. Temperature can also be measured in degrees Celsius, but the SI unit of temperature is actually in kelvins. So if temperature makes up the average kinetic energy, or if temperature is a measurement of the average kinetic energy of the particles of an object, what then is thermal energy? Thermal energy is simply defined in your book on page 139, the sum of the kinetic energy as well as the potential energy of all the particles. That's what's important. We're still talking about particles that make up an object. So if you total that up, the kinetic and potential energy of the particles, that is called thermal energy. I want to put this in front of you so you can refer back to it. This is also on page 139 of your book. I'm going to put it right there, and I'm going to stop right there. You can see that when particles move faster, they have more kinetic energy, but there's also more space between particles, so the potential energy increases as well. So the total of those two is thermal energy. So we've covered temperature, we've covered thermal energy. What then is heat? Heat is described on page 140 of your textbook, and it is defined as energy that is transferred between objects due to a temperature difference between those objects. Uh, Imagine, I'm going to put my hand on the board here. As soon as I put my hand on the board feels cold to my hand. What's happening is energy is being transferred from my hand to the board. There's a higher average kinetic energy, a higher temperature of my hand versus the board. So what's happening is when the particles, the fast moving particles of my hand are colliding with the slow moving particles of the board, I'm actually transferring energy from my hand to the board, and that is heat. Heat. It's important to note that heat is always going to go from an area. Heat is always going to be transferred from an area of higher temperature to lower temperature. So once again, when I put my hand on the board, heat is flowing, energy is flowing from my hand to the board. We covered temperature, thermal energy, and heat in section 5.1 of this chapter. I'm sneaking in conduction, convection, and radiation. We're still in lesson 12, chapter 5, section 5.2. This covers pages 144 to 150 of your textbook. This section talks about how thermal energy is transferred three different ways: conduction, convection, and radiation. The first one is conduction. It's defined in your text as the transfer of thermal energy by collisions between the particles that make up matter. Just a second ago, you saw me put my hand on the board. When two objects are physically touching, typically two solid objects are physically touching, heat is going to be, or thermal energy is going to be transferred through conduction. It's got to be touching. My hand is touching the board. Heat is flowing. Thermal energy is flowing from my hand to the board. Another example, I was thinking my daughter's just made omelets. You put a metal pan on the stove, on the oven. Um, the 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 touching of the metallic objects from the burner to the pan is a transfer of energy through conduction. Next is convection. Next, we have convection. Convection is defined as the transfer of thermal energy in a fluid. Well, what's a fluid? A fluid is something, a substance that can flow, that has enough particle motion. We're still talking about the movement of particles. A fluid is a substance that has enough particle motion where the particles can slide past one another. In short, a fluid is either a liquid or a gas. The particles have room to move around. So water is a fluid, milk is a fluid, air is also a fluid. So how does thermal energy get transferred via convection or through convection? So what happens is the particles are going to slide past one another, and there's usually a difference in temperature from the two different fluids. So we have what's called a convection current. Imagine, think about air. You have cold air which settles to the bottom of in any area because it's more dense than warm air. So what happens if you apply heat or thermal energy to a fluid, it's going to go up. Uh, we always think of heat. Heat rises. Heat doesn't rise. Hot air rises because air is a fluid. So hot air is going to go up, and when it does that, it cools off, it becomes less dense, and then it comes back down. We have here what's called a convection current. It goes in this particular direction. I just thought that I didn't give you any examples of convection. What would a classic example of convection be? Think about fluids, think about liquids, think about gases. The reason why we have air currents on planet Earth is because of convection, because air is a fluid. Think about ocean currents. Those are also because of convection, because of water. Lastly, we have radiation. Radiation is defined as the transfer of energy by electromagnetic waves. Your book gives a couple examples, such as light or microwaves. It's important to understand that radiation is the transfer of thermal energy in which you do not need matter for radiation to travel. Invisible waves, waves that well, mostly invisible. Things like microwaves, ultraviolet rays, X-rays. Humans can see some form of electromagnetic waves, and we call that light. But most of the time, they're invisible waves that travel. They can travel through nothing. I want you to think about the sun. The sun is 93 million miles away from planet Earth. Now, the sun we know is very, very hot at the core and on the surface, but how do we get energy from the sun? It travels in the form of radiation, okay? Visible visible light, ultraviolet light, a bunch of electromagnetic radiation, and that's how we get our heat from when I say our heat, that's how planet Earth gets its heat. I want you to think of putting your hands close to a fire. You're getting heat through radiation. Invisible waves for the most part, and that is conduction, convection, and radiation.